Okay, this is 2006, Form A, I guess. Number 3, 15-pointer. 2-point charges Q1 and Q2 are placed 30 centimeters apart on the x-axis as shown in the figure above. Charge Q1 has a value of, and this got a little format crazy, but this should say -3 times 10 to the -9th coulombs. And I made the change on your sheet. It tells you the net electric field at point P, which is right here, is 0. What is the sign of charge Q2? Well, if this is a negative right here, the only way to make point P 0 would be if this is positive. And that should pretty much do it for your justification. The only way to cancel an E caused by a negative Q is with a positive one. A negative electric field will only make things stronger. Okay, the next one says we need to calculate the magnitude of the charge Q2. Okay, so what we know is that the electric field here is 0. So what that means is that the electric field due to Q1 and the electric field due to Q2 have to also cancel out. So let's just plug in what these things are equal to. Electric field is equal to K, Q over R squared, plus, we know this is going to be negative, by the way, because it's a negative Q1, plus K, Q2, which is what we're looking for, over R squared. Well, K is a constant, so that's not a problem at all. And we know just about everything we need to know, so it's really just a matter of plug and chug. So we have negative K, which is negative 9 times 10 to the 9th, and Q1, which is 3 times 10 to the negative 9th, all over the distance between them squared. Well, if you look, the distance between P and Q1 is just 0.1 meters squared. And then plus K, once again, is given as 9 times 10 to the 9th. Q is what we're looking for. And the distance between them is 0.1, 0.2, 0.3, 0.4 meters squared. And after you go through all the trouble of subtracting or adding this to the other side, and then dividing and multiplying everything out, you end up with a Q2 that has a value of positive 4.8 times 10 to the negative 8th coulombs. And that's good because you want it to be bigger than Q1 because it canceled out the field from a greater distance, so it has to be bigger. All right, part C says, calculate the magnitude of the electric force on Q2 and indicate its direction. So I'm going to grab that picture. So if I need to find the force on Q2, the only thing that exerts a force on Q2 is Q1. And the equation for this is K Q1. Don't forget its absolute value, so we won't worry about signs until the end. And it's a plug and chug matter again. 9 times 10 to the 9th, 3 times 10 to the negative 9th, 4.8 times 10 to the negative 8th. And the distance between them is 0.1, 0.2, 0.3 squared. And once you solve that out, you find the force between them is just 1.4 times 10 to the negative 5th newtons. We need to indicate its direction. Well, since they are opposite charges, you could say this is the force on Q2, so this would be to the left. And don't forget your units. And letter D says, determine the x-coordinate of the point on the line between the two charges at which the electric potential is 0. Okay, so once again, you have to make a couple mental adjustments here. We need to find the point between these two charges. So I'm going to say wherever that point is, it doesn't even matter how accurate we are. I'm going to call that D, and I'm going to call this distance 0.3 minus D. And here's the reason, is I know the total distance is 0.3 meters between them. Well, that means it's D plus some distance. So if I want to find what this distance is, I just do x is equal to 0.3 minus D. So that's the distance. And that way, if you look, I've only got one unknown. So now, in order to solve for your voltage, we know that voltage is just equal to V1 plus V2, which is just KQ over R plus KQ over R. Once again, taking your signs into account and doing a little plugging and chugging here, you know plenty of information here. So K is 9 times 10 to the 9th times this initial Q, which is Q1, which was -3 times 10 to the -9th, all over the distance between them, which is 0.3 minus D. And then over here, we got plus K, which is 9 times 10 to the 9th, times the value of the charge, which was 4.8 times 10 to the -8th, all over the distance between them, which is just listed as D. And we know that those two things together have to equal 0. So I'm not going to do the algebra with you, but you can go through, and once you solve for D, you find that the distance is it's 0.282 meters, and that is this distance right here. And the last question says, how much work must be done by an external force to bring an electron from infinity to the point at which the electric potential was 0? Well, we know from our equations that work is just equal to, work is equal to change in energy. And if you look on your equation sheet, which I know you have, you know that's Q times V. Well, in part D, we just found out that V equals 0. Okay? And the reason is because the electron will do it. You don't have to do any work. The electron will do that all by itself because that second charge is a positive charge.